So, do you own one of these? It's the same chip as in here. Have you ever tried to program it with one of these? These are FTDIs. Have you ever had a problem? Like you hooked it up right, but no matter what, it wouldn't work. The chip would not take the code. Well, I figured out some reasons as to why. First off, you have 1 microfarad cap right on the reset pin in series. Now this is very important. So there, say the reset on the FTDI, the DTR, yeah, that goes right there. And you can look on the internet and you can ask, why do I need this? What's the point? And I looked all over for it, and it does not tell you. It just says, here, you need this. So here's my idea as to why you need it. So the idea is to is to have this thing on, and I need to reboot it. Now that's the key word, to reboot it. To make it go off and then back on. And how do you do that? Because the FTDI, if you hook it up to the DTR pin, when you first plug it in, it stays high. Good, it stays high, which means this chip will be on. When you start uploading the code, it goes low and it stays low. The problem with this is if the reset pin stays low, the chip is shut down and it stays off. So you can't upload code to a chip that's off. That's the problem. And I figured out why you need this. Okay, so let me just hook this up and give you an idea. Let me get a jumper, a very long one. Now go with a short one. Boom. Like a pro, right? All right. So, like I said, when this thing is booted on, then the chip is on. When I plug this one in, this reset stays high. Now since voltage is how should I say, perspective. That's why this cap will do nothing at all. Why? Because if I have a 10K resistor here, so let's just go boom and imagine it's hooked to VCC, which is the 7th pin. So there, we have this pulling it up. Say this is a 10K ohm, and boom, it pulls this chip up. Now, we have around 4 volts right here, and we have 5 volts coming out here. What's the cap doing? Nothing. It's doing nothing. Why? Because we have 5 volts on this side and 5 volts on that side. It's relative to either pins, it's around 0 volts. If anything, this thing, perspective-wise, is hooked up wrong. So look, you have the ground pin here, you have 5 volts here, you're getting around 4 volts here. So if anything, this side is positive 1 volt. So, in layman's terms, imagine this is 5 volts, imagine that's 5 volts. This is at 0 volts because these are both 5 volts. In order for a capacitor to work, you have to have 0 volts on one side, 0 volts on one side, and 5 volts on the other. That's how it charges up. It needs ground and it needs a VCC. So I figured out what it does. This thing stays high, which means the capacitor does nothing. It is not charged up because there's no connection to ground. But then when I initiate the code to upload, it grounds it. So now we have 4 volts, technically, let's just say 5 volts. 5 volts, and 0 volts on this side, which means the capacitor is now hooked to ground. It can charge up now. It has a path. So here's why we need it. Because 5 volts here, 0 volts here, what it's going to do is it's going to suck. Let me zoom in on that. Okay, it's gonna suck all the power coming in, and it's gonna go straight into the cap. Because the cap is at 0 volts, it's gonna take all the power it can get. Which means relative to the reset pin, it's not detecting anything, because the path of least resistance right now is the cap. And then the cap starts to fill up. And then it starts taking less. And now it's at 2 volts and it starts taking less. And now this pin is picking up around 2 volts. And now it hits 2.5. That is technically, for this chip, it's a positive. It is high, which means it boots back up. So do you see what happened there? The capacitor had positive, that went to the ground, and then it started sucking up all the power it can get to charge it up, which brought this pin low, because the power was not going into this pin, it was going into the cap. The cap was sucking up all the current, sparing none for this pin here. So we brought it low, chip rebooted, or it shut down, and then as it started to charge up, this pin started detecting around 2.5 volts, and it brought it back up high. So the chip here shut down, then as the capacitor filled up, it booted back up because the voltage went low, high. Now, I don't know why, but the FTDI chip, it should have this built in. It should go low, high. But apparently you need the capacitor to do that. That's why you need it in series. Now, if I were to have this in ground, so that's at the ground, that would not do the same. Why? Because this charges up. As soon as I bring it to ground, the only thing it would do would be to delay the time that it goes low. So this would go low, and maybe half a second later, then this pin would go low. That's why you cannot have it in parallel. It's got to be in series. Very important. Now, if you've done this, and you still can't figure out why your stupid chip won't upload the code, I bet I know what the problem is. Move that out of the way. Actually, I kind of still need that. And it does not involve this at the moment. Now, FTDIs, an important thing to notice is that the FTDI, let me zoom in on that. So you have the TX and the RX, that's called UART, or serial. Boop. So it uploads its sketches on these pins here. Now, the Uno comes with a bootloader. What this bootloader does, why don't you focus, buddy? Okay, what the bootloader does is it actually tells the chip, when I'm booting up, check on these two pins for a sketch upload command. As you can see right here, here's your TX and your RX, pin 0 and 1. Those are these two right here. Now, this searches for the upload that is initiated from your computer, from your software, onto this chip. Now, have you ever uploaded to a chip via one of these? Or maybe you did something like me. You made a little chip. Let me see if I can put this on. Boop. Sorry, my camera work is terrible. Boom. And then you put the chip in there and it uploads. Now, this isn't uploading through serial. It's uploading through, where's the chip that I had? There it is. Boop. Through SPI. Through MISO, MOSI, and clock. Master in, slave out, blah, 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 blah. This is completely different from this. This uploads the sketches. This can also upload a sketch easily. Only problem is it uses SPI, which has direct access to the memory. This overwrites your bootloader. I mean, okay, look, you can still upload a sketch to this. It will work. But your bootloader's gone, which means uploading through serial will not work. Why? Because there's no bootloader. That's why. So if you've ever hooked up your serial, and you've hooked up your cap and your pull-up, and it just does not work, your bootloader's gone. It's gone because you uploaded it through this guy. You need to burn your bootloader onto it first. So you use this guy, right? Boom, boom, hook it up, tell it to burn the bootloader. Now take it away. Don't use it for anything else. Don't use this. Use your serial. And then it will work. And chances are you have bad luck like I do, because this is the AtMega 168. And I don't know what I did to this thing. I wrecked it because this thing will not upload code through the serials. I'm pretty sure that I blew it up. I was messing with inductors and voltage was going into places that it was not supposed to go. I feel really dumb. Yeah, so this thing, serial bootloader, does not work. I can still upload code to the SPI. Don't know why, but it works. And I had this problem forever, but I swapped the chips and it finally worked. I tested this out and I did some research. Boom. My little chip. I have a little cap underneath here you can't see, but you can see my header right there. See it? I can finally upload to it now. Because I figured out I needed a new chip because I broke the darn thing. How dumb I am. And two, I needed this and a bootloader. So for anyone having the same problem that I was, make sure you have a bootloader. Go to the Arduino IDE, you get the tools. It says burn bootloader and you're good to go. Now this is not an Uno. This chip here it does not have a 16 megahertz oscillator. I'll show you on this chip. Let me set this down. Okay. Let's get a look right here. See that chip right there? In the center? That's the oscillator. That's at 16 megahertz. Now this one right here is running at 16 megahertz. This is a crystal, and it's running that chip. So don't think that runs that. It's actually that runs this. 16 megahertz. This chip does not have one unless you want to buy your own. So if you're going to upload a bootloader, make sure you download one that is compatible with the internal 8 megahertz oscillator inside of the chip itself. Your code will not run right if you have a 16 megahertz bootloader and no 16 megahertz crystal. So that's just a word of advice for anyone still experimenting with these chips and knows little about how to upload to them. I figured this out the hard way. And that is the tube that broke my chip. This is called a Nixie tube. Super cool things, if you ask me. They display numbers. It takes 170 friggin' volts to run these, which is why I have this guy here. Why? Because my other one, not this one, but I had two and it blew it up. I accidentally got the voltage up to 600 volts. Yikes!